Our core values are this reactivity, so interactivity as a fundamental principle, instead of a package that you download later. And then reproducibility and doing it by default. So Julia has really good tools for reproducibility, but you have to know how to use them. And so with Pluto, we take those tools from Julia and we apply them by default. And then the last one is education first. So designing for teachers and students and always taking their needs above those of pro users.
Welcome to Inspiring Computing. This podcast is where computing meets the real world. This podcast aims to trigger your curiosity by talking to proficient and advanced users of MATLAB, Python, and Julia, who use these tools to deepen their understanding of the world by simulating it, exploring trade-offs, and gaining insights that help their companies add more value. In addition to proficient users, we will be also talking to product marketing, toolbox authors, package developers, and library maintainers to see what drives the development and what issues they're solving for others to benefit from.
In this episode, we explore Pluto. It is a Julia package which enables people to write Pluto notebooks. These notebooks are used by hundreds of thousands of people around the world to help explore the world around them. We talked to Fons to understand how he and some of his co-creators started this project, what motivated them to create yet another notebook framework, and what are the key differences towards other notebooks such as Jupyter, MATLAB editors, and maybe a little bit of Observer. In addition to this, we will also explore how Plutos are used in education, with Gerhard's experience as a teacher and a community manager, as the team collects a wide variety of use cases of where and how Pluto is used and how it helped people explore the world around. But not only do we understand and explore how it got going, how it's used today, we're also taking a sneak preview of what's to come in the future and understand how the community and the team make their decisions of what are the new features to be implemented and why. And it all revolves around some of their guiding principles that the team has put in place.
First of all, welcome to Inspiring Computing. I am super happy to have both of you on. So you, Fons, we met at a Julia meetup, and Gerhard, we met online, and I'm very happy to have the two of you to talk a little bit about Pluto and the value and how you use it and where it's going. But before we get into that, maybe you can tell me who you are and how you got started with Julia/Pluto. And let's start with you, Fons, because we're doing this alphabetically.
Yeah, thanks for having us. My name is Fons. So I started with Julia because of my university. They were using Julia in one of the classes. It was scientific computing, so numerical mathematics. And I thought, wow, this is really cool. And then there was a big holiday, and then there was a big pandemic. And so that's when I started Pluto. Started as a hobby project to improve teaching, but now it's more than a hobby project.
In the meantime, you've recruited some awesome developers and helpers. And
yeah,
Gerhard's one of them.
Yeah, exactly.
So Gerhard, how did you get started with this?
Yeah, hi, I'm Gerhard. Thanks for having me here. It also started at university. I was teaching a lot, and then I had this chance to create an online MOOC, massive open online course. And I always wanted to have something, an interactive simulation in a web page where I don't have to register or buy or do something like that. And then I searched on the internet and I found Fons, a video Fons, how I introduced Pluto, and that's actually the way how I went on the Julia path. And yeah, since then I'm a Julian guy, I would say, and Plutonian.
So Plutonian, I like this term. So I don't know if this is official or not, but we can coin it. So maybe then, Gerhard, what is exactly Pluto? So I'm sure Fons is his own description because he started it, but tell me, what is Pluto?
Pluto is a reactive notebook which enables you to program just in your browser, and it's super fast because Julia is super fast. And the most important thing, it's interactive, so you can add sliders. It's very, actually from a visual point of view, it's very appealing. So you can also have emojis and LaTeX and Markdown, and all you need, you can just write down in your code and it looks super cool.
So it feels like, so would it be fair to say it's like a MATLAB live script or a Jupyter notebook,
exactly,
but more aimed towards teaching? Is that the idea behind it?
Yeah, for me it is. I also compared MathWorks, the live notebook, and also Jupyter notebooks. But the game changer is that you really can make it accessible as a link on a homepage and even make it reactive. So you don't have to register, you don't have to install anything. You click on a link and you can move sliders and see a simulation going. And this was for me like mind blowing. Hey, I can create a really cool homepage now, which I can make available to my students. And this was not possible with MathWorks because you have to register. And also for Python, it's not that straightforward.
So then I guess I have to ask you then, Fon. So how did this actually get started? You must have had a vision where you're tackling a problem that you said, hey, I wish I could learn computational thinking in a better way. Or tell me what drove you to get going with Pluto.
Yeah, a couple of inspirations. But one big reason was for my bachelor thesis, I worked on the electric power grid of Germany, and I did all of these simulations in Python, because there's a nice Python package, and I didn't know Julia yet, right? And so I did all of these simulations, and I used a lot of Jupyter notebooks. And then at the end I had this big result of the map of Germany, and then which lines will explode and what's going to happen. And I really wanted to visualize this and click somewhere on a line on the map and then see the effect if that line shuts off. And this was super difficult. So I already knew JavaScript, so I was trying all the hacks to implement this in JavaScript in Jupyter, but it's really not meant for this. And so what I ended up doing was exporting all of the possible results to a big JSON file, like 50 megabytes, and then I put that online, and then I made a JavaScript notebook in Observable HQ, which downloads all of the possible results, and then I did my whole visualization. And so Observable HQ is this reactive, interactive environment for JavaScript. But yeah, so I was facing this problem where I have to choose between Jupyter, where I can use nice scientific languages like Julia and Python, or I can use Observable, where I can use the language of the web, JavaScript, and I can make interactive stuff, but I cannot really do my science because there's no power grid analysis package for JavaScript or something. Yeah, that was a big one. Can we make a notebook environment where this interactivity is already there and where you can write JavaScript like as a part of the notebook? So that's like a different angle to what Gerhard already mentioned. So we talked about a notebook for education, like making it really nice to publish stuff. So this was the technical inspiration, doing like a web-first, modern web technology notebook for Julia. And then Julia is really exciting. Can we make something more modern that only works on Julia? And it's technically really interesting to make a notebook for one language instead of, like Jupyter, making it kernel independent. Because we can do all of these cool integrations with Julia itself, like reactivity and stuff. But then the other reason for me is I think programming is too difficult and we have to make programming easier, and I want to contribute to this. I think it's too hard for students to get started with programming and all of these things like environments and command lines and install scripts. It's too hard and we have to make it easier.
I want to double click on that. When you say getting started with programming is too difficult, walk me through that. There are gazillion programmers out there. Something must be working. So is it a certain type of person that is struggling with this? Walk me through this a bit more. And then maybe, Gerhard, you can tell me your experience about that.
Yeah. So Matt Hubert made this like digital essay called "When I Sit Down at My Editor, I Feel Relaxed." And I think he explained this really well, how there's at the start of this essay, so it talks about an editor that's designed to be easy to get going and all sorts of other stuff. And at the start he explains, okay, typical programmer baby steps are open a text editor, create and save a new file, open a new terminal window, navigate to the folder where you created your file, now run your program. But then actually there are so many questions behind this, like text editor, you mean Word, you mean Google Docs, create and save a new file, where do I put it, what is a file extension? And then comes the terminal, right? What is the terminal, how does it work, how do I find it, how can I navigate it? Why is it suddenly black with white text? And then, navigate to the folder. There's suddenly a stateful system that you normally don't have in GUIs. And then there's all of this stuff. We just build up these difficulties at the start to just get started with the basic stuff. Like initiate your environment, get your packages, and now run my code. That's too difficult for people, and we have to make that easier.
So when you say manage your environment, that's also, I guess you're coming from the Python world where you create your virtual environments and every environment is separate and it's not always clear, is it Python 3.10, 3.11, and is the packages right? And there's a bit of a hurdle to get there, right?
And of course, people can write really detailed descriptions, like they can maybe make a YouTube tutorial where they really film their screen and they say, okay, now I click here to open the terminal, now I type this. But if you make a small mistake, the whole path will be different for you. And your computer is going to give you all of these messages like, oh, pip is outdated. You should do pip install update pip. And you just get so confused, and there's so many concepts that you really shouldn't know about. But they're all thrown at your face at the start.
And is that where Pluto the idea behind Pluto was, okay, let's remove all those barriers so people don't get scared or confronted too quickly with those things? Is that it?
Yeah, I think in the first months, it was just a cool technical challenge that me and my friend Nick were working on. Wow, reactive notebook, wow, web first. But then later I thought, wow, this is actually a really good platform to work on the things I also really care about, which is making stuff easier for new programmers. And so now you see that's mostly what we work on, is trying to see what new programmers struggle with and how we can make that easier. And we're not really working on too many new spicy features or advanced features. We're mostly working on features that really help new users.
I guess I want to get a bit of Gerhard's opinion here on this teaching. So I think, Gerhard, you've taught before. Looking at your profile, I think you used to teach with MATLAB, and now you're teaching with Julia and Pluto. So can you maybe give us a concrete example of a course that you've taught and how that Pluto is effectively used and how that changed from the previous way of doing things?
Yeah, so what I experienced, for example, are students who have a course in also the same thing we talked about already, a course in Python, and they struggled installing Spider and a lot of packages. And it took them a whole day to have everything set up. And the other thing, we also have MATLAB in our curriculum. And this is quite a good user experience because you have a program, but it's not for free. You have to pay for it. And this is also a barrier for those who cannot afford expensive programming environment. And Pluto is different in that respect because it's super easy and it's for free. And it's, I think, to enable students or young kids to program, it has to be barrier free, and you have to think about the user experience. So I click on something, should be the icon, and I have the programming environment ready, and not having to struggle with what to install and so on. And so my experience was, or is, that Pluto and Julia are much more straightforward. And this is also the thing that Alan Edelman told in his talk about why developing Julia, it's designed as a language between people and not a language from human to machine. And so it's very natural, or they try to be very natural in how the syntax looks like. And that's why I really recommend and appreciate Julia and Pluto, that straightforward and it minimizes those barriers.
Then maybe just to make it a bit more concrete, can you walk me through in a few words? Like, okay, I want to get started. So what do? I go to Julia, I download Julia, and then how do I get going with Pluto? And what is the first thing I should do as a user to try it out?
Yeah, to get started, you go to plutojl.org, and then it explains it. Right now it's 4 steps, and we explain those 4 steps like really clearly, but we're working on making it 1 step. So maybe by the time you listen to this podcast, you go to plutojl.org, and it's just 1 step. Yeah.
Very good. Okay, so then maybe to understand a little bit more that from a programming perspective, so Julia is very powerful. I think it's very useful. So when you look at the Julia ecosystem, do you find that getting started with Julia was also difficult, and Pluto is a layer on top of that which makes life easier? So can you, because in my mind, Python, the environments, the packages, the versioning, that's usually a headache. How does Pluto solve that again?
Yeah, so also, I forgot to mention this, but Gerhard mentioned it a bit. So Julia is the really cool programming language, not created by us, created by other people. Julia also has a really good package manager, also not created by us, but it's really good. Julia's package manager is really based on experiences that they had with other ecosystems. And then Pluto is a programming environment for Julia, written in Julia and JavaScript. So that's a distinction. And then about getting started with Julia. Yeah, Gerrit, what do you think the difficulties are with the setup part of starting Julia?
There are also some bad points with Julia. For example, if you want to plot something, there are different ways how to do things, and you have to get into the syntax and stuff like that. So compared to other like programs out there, you don't have a button where you can click and you have a line. This would be a graphical programming language. And for me, Julia was very natural because I came from MATLAB, and it's rather similar syntax, I would say. You have types, which is a bit unusual if you think of Python and MATLAB. But on the other hand, it's so fast, so this is really a bonus. And what I, for example, did, I watched a course, Fonts co-created computational thinking from MIT, where you got to learn some of the concepts behind. So multiple dispatch, or Fonts can actually explain them better, but for me it helped a lot how to see how to work with images, with colors, with units. So to some extent, Julia is so smart, and you can just add, I think, the units package, and then goes through every calculation step you need. You have a matrix, you have an array full of units, and even the uncertainties. So they're so clever. It's composable. This is the word I missed. So you can compose different concepts and they just work together. And if you just think in Python, other programming language, you have one cool feature, but you cannot use it with the other cool feature. And I think Julia, from its design, allows you this. So you can really put things together.
Yeah, this is a really cool concept in Julia. And I think people who are interested in this composability between packages, there's this talk by Stefan Karpinski called The Unreasonable Effectiveness of Multiple Dispatch in Julia. And you should just look it up on YouTube and you'll really be amazed. It's also comparing it to C++ and Python and maybe comparing it to something you already know. Yeah, I think about getting started with Julia. It's also, is it your first language or your second language? Makes a really big difference because I'm still not sure if Julia is great as your first language, depending on your age. But maybe if you're already a scientist and you have done quite a bit of mathematics in high school or at university, maybe then Julia is actually a really good fit for your first language because you can tell it's made by mathematicians. So when you read the manual, which is really well written, I think, you'll find like all of these mathematical ways of thinking in the way they explain Julia. So at one point, it even explains something using category theory or something. No, wait, using group theory. Yeah, like in the documentation about strings, it suddenly brings up group theory and like being a commutative algebra or something like that. And I think to me that's great. And now I know what they want me to know. But yeah, it depends on your background.
It is very technical and you can go very deep, but it also has the surface which is just super easy and lean. And so I always thought if you just have a proper introduction to the basics, like how to add two numbers or like for the really simple stuff, it's super cool. Because if you want to calculate the sign of a number, you just do it. Sign, bracket, number. And you don't have to use like adding a package or something. Or if you want. So what's really cool is that at least you can translate the math you learn at school directly into code. So this is, even if you are undergrad and you want to use it as a calculator, it just works. You have to use radian, not degrees. That's maybe you have to know that. But what I really, it's not just about using the programming language, but experiencing it. So when I use Pluto notebooks, I always had a promise. I want one click and having an interactive simulation. And that promise was there. And the second thing I wanted is, I want the second click, I want to change the code and look behind. And this also works because there is a button in each Pluto notebook where I can actually download the file and then see all the cells, what's behind the cell, how the cells are created or what the code is behind. And this is brilliant. Imagine if you see a cool interactive homepage and you want to use it. With Pluto, it's possible. You download it and this is sharing of code. This makes collaborative programming so cool. So a student in a class can prepare a notebook and implement an algorithm. And then the other student says, hey, this is fast, I take it. Or let's make a benchmark, a competition. Whose algorithm is best? And that's what I really like, that Pluto enables to share code.
So it's interesting because when I first played around with Pluto, actually, there were three things that caught my eye, and I'd be curious to get your take on it. So the first thing that I was impressed was it always runs. So I've always had this thing in Jupyter notebooks. There's a large percentage of them, or a relatively large percentage of notebooks that are on GitHub, and they just don't run because people run it in a different order. So you run one cell, you run the other one, you get the results, and if you don't run the whole thing from scratch again, it doesn't work. So I've always been a bit annoyed by that. That's like, okay, so I need to know the order in which cells are executed, and it's not a linear thing. So that I thought was very elegant. The second thing I thought was super cool is the built-on package management, because it's also a bit of HTML that you can connect to a camera, right? So all of a sudden you can have a camera feed in there with limited code, a slider bar, connecting with a microphone. You get all these perks from the web that you can just put in there, and it's accessible, and you don't need to be a computer scientist to say, okay, how do I get my web feed? I just want to have a camera and record my voice and do some math and understand what it means to change frequency or playing it backwards or whatever, right? And that exploration becomes so much quicker and easier. And then the third thing that actually caught my attention was the help. So most environments, when you want to know a bit more information about what is going on, you do a Control-T, open a new tab, you Google, you go to Stack Overflow, you open up your 10,000 documents, and I really thought it was very elegant the way that help is just right next to you, and it's appearing as you go, as opposed to a very separated environment. But those were my three big things. I said, oh, cool. I like this Pluto. This is cool.
Yeah, I agree. I think it's cool. We try to make it cool. I'm happy you like it. I think, on our website, so we try to make a website where we explain our ideas behind Pluto. Sort of our core values are this reactivity, so interactivity as a fundamental principle, instead of a package that you download later. And then reproducibility and doing it by default. So Julia has really good tools for reproducibility, but you have to know how to use them. And so with Pluto, we take those tools from Julia and we apply them by default. And then if you know what you're doing, you can do something else. So that means we're reproducible by default. And then if you want something else, you can. And then the last one is education first. So designing for teachers and students, and always taking their needs above those of pro users. If you could go into these three things you mentioned.
Just curious on your take. So from a technical perspective, I think there's a lot to be said, right? For example, the code can change above or below, and then it's always connected, the variables are connected. That's pretty cool. So can you tell me a little bit about the thought behind that, and how difficult was it to actually implement underneath the hood?
Yeah, so this is totally inspired by Observable in JavaScript, but also by spreadsheets like Excel. So in a spreadsheet, it's always updated. And I'm talking about formulas where you can write, for example, your data in the first column, and then your second column you do 2 times the value on the left. And then you see that when you update the first column, the second one updates instantly. And you expect this by now. It would be strange if it didn't do that. And this is how millions of people know how to program, like with reactive spreadsheets. And then there's less than 1 million, or I don't know the numbers. But there's much less people that already know how to program, but we think maybe all of those people who know how to use spreadsheets, maybe we should do what they expect instead of what the Jupyter users do.
The cool thing is it really allows you to put hands on the things you code. So you can change a parameter and see how it changes. So interactively, like really with your hands, you take the mouse and you hover the slider and you see what's going on, and it's really fast. And you cannot do that like in an easy fashion with a C code or with MATLAB. Actually, I don't know how to add a slider in MATLAB. There is a way, I think, and also in Python. But this simple tool is just to be able to really comprehend the model, to tune it, to change it, to make it much more accessible. For me, Pluto was like the mouse at your computer, or the touch display. Touch display is maybe the best comparison because it allows you to enter things and also to visualize things. So you have the plot directly, and if you just work with a console, you don't see the nice plots, the Unicode plots, which is also a funny thing in Julia, that you even can plot in a REPL. But so it's Yeah, this is the fast thing. So normally if you have a computer, you have the input, you have the processing, you have the output. Pluto is input and output, and in behind Julia, it's so super fast. You can even directly work on a GPU, which is really fascinating for me. You don't need CUDA, you don't need extra compiling steps. You just, and this is so simple, you just write, for example, an array, line, greater, and then GPU, and this moves the whole array to the GPU, and everything you write below is happening on the GPU. This is so amazing. This is not working in other languages in that easy manner. And I have to say, yeah, I'm using Julia also for autonomous driving tasks, perception stuff like that, and on supercomputers, and you don't have to compile things with difficult which compiler should I take and stuff like that. So it's so elegant. I really like that.
You touched on a couple of things, right? So before we take a deep dive onto that, Gerhard, just to follow up on the order of execution, because I think this is a super important thing, right? So I think most people, the way they think, or at least if I go back to my university days, I would say declare a variable. So I say A equals something, and then I write an equation, I plot it out, and then what you're inviting people to say is what happens if my parameter A changes? What's the impact of change? And that's a visual way of understanding maths, right? It could be physics, right? If you're changing a force, if the force is higher, when do things crash? I don't know, going orbits. It's a very natural way in scientific thinking. You have parameters, you want to understand the change. But what I often find is you only realize that you want to change things after you first declared them, and then you declare the changes below, you run it multiple times, and then if you go back at the beginning, you don't get to the reproducible results. So you've put that in place, that at least from my understanding is from an educational perspective, it really doesn't matter where you're changing your variables. That can aid or help people explore and understand the concepts without the programming, which I think is partly where the Jupyter Lab or notebooks kind of falls apart. And I think talking earlier to you, you were talking about some of the courses that you use, Julia. Can you give an example where you've used these slider bars to help people navigate through these insights that you want to get there?
Yes, I created this course on probability theory, and I wanted to provide this interactive simulations in a very easy way. Just one click and you're there. And I also created quiz questions where you should answer the questions with the simulation. So you had to tune the simulation and the parameters of the simulation in such a way that you could empirically find the answer. So which values is it? And then you try to tweak around with the sliders, and then the program tells you. And you can then think, hey, this program is cool. How does the program actually work? And then you can have a look behind.
Nice. So it's a bit like, can you figure it out intuitively, yes or no? And then you're giving people the motivation to figure out understand the physics behind it.
Exactly. And the cool thing is you can give this simulation to a totally beginner who has never coded in his life, and he just can experience what the thing is doing. And then in the next step, when he's like a little bit familiar that the thing is doing something good, he can explore the code. And this also diminishes a barrier where some people say, yeah, coding, can't do that. But if they can use the code first and then see how it's going, this is so cool.
But to achieve that, Fawn, so maybe you can tell me, because Julia as a language, just like Python and just MATLAB, it is interpreted sequentially, right? It is a sequence of things that get called. So how did you link all the variables independently? Is there some voodoo magic happening behind the scene that you rewrite the script, or I don't know, I'm curious.
Yeah, exactly. I think it's nice to say that, like, when you hear all of these amazing things from Gerhard, it sounds like magic, and maybe it also sounds like something that you're not able to do. But this is not true. It's not magic, and you can do it. The big idea is it's called reactivity, and who uses reactivity has a different definition for it. But for us, it means a notebook. So Pluto runs notebooks, and notebooks are a bunch of cells. Cells are tiny scripts. So, for example, A equals 5, that's a cell. And then B equals 6, C equals A plus B. Those are 3 cells. And so you see this visually, little bubbles with code and their outputs. And so for C, you would see C equals 11, right? Because it ran that code. And so in Jupyter, you have the same concept, and they're also ordered, so top to bottom, and you can run them one by one. And you can also run them bottom to top if you just click on the little run buttons, bottom to top. So you are in control of execution order. In Jupyter, it's really common to do run all cells, which will run all of them top to bottom. So if you assume that the person did this when they sent you the notebook, then you can say, okay, Jupyter is an environment that runs all cells top to bottom, and Pluto is not. So we don't run cells top to bottom. We run them the way we want to run them, which is in topological order. And this means Excel does this too, or any spreadsheet. They also run cells in topological order. So in spreadsheet, it doesn't run all the cells, like execute all the cells in order, right? Also not top to bottom. But it figures out which cells come first, and then it flows to the computational graph and runs them one by one. And we do the same. So we know if you write a bit of Julia code, we use Julia to find out which variables you use and which you define. So in the C equals A plus B example, you define C and you reference A and B and plus. You can also redefine plus in Julia. So you have 3 references and 1 definition. And those are like your edges in the graph, the computational graph of your notebook. And we follow these edges in a search algorithm to find the order in which to run cells. And we do this automatically. So when you redefine A, we flow through this graph and we find everything that also needs to run, and we run it as well. And now the big thing is sliders are not, when we talk about sliders and types of interactivity, it's not a different kind of interactivity, but it's built on the same kind of interactivity. So it's built on reactivity. So this example notebook, A equals 5, B equals 6, C equals A plus B, it's already interactive because I can just sit here and change the definition of A and run it, and I will see that C is changing. So that's a type of interactivity, right? And if instead of A plus B, I was doing a cool simulation with A and B as parameters, that would actually be super useful. That I built, like, I created an interaction, right? Even though I didn't write callbacks, event loops, main loop, all of this stuff that you might be used to from game development or any kind of interactive work. For us, your code defines the interaction. And so for a slider, you just say, instead of A equals 5, you say bind A to a slider between 1 and 10. And the rest of your code is the same, and it will display the slider. And when you move the slider, we send that back to Julia as a definition of A, and we flow through the graph. So reactivity is also how all our other kinds of interactivity work. They're all based on this bind principle, where you bind like a slider or a text value or a webcam face data, and then that webcam data is just your Julia variable. Yeah. So this is, I think, really powerful because people know how to use spreadsheets, right? Reactivity is something that you will pick up in seconds. It makes sense instantly. It's not a new programming paradigm that you need to learn. You know it. And then
you can also think of it as Simulink cells. So you change the value in one cell and you have this dependency graph, and all the other cells get new signals and are updated.
Totally, yeah. Think of it as a graph that you see in these visual programs.
A big network.
And because you already know how to do reactivity, you also know how to do slider-based plots or webcam-based QR decomposition visualizations. All of this stuff, you already know how to do it because the interactivity principle is just global variables being used. Yeah.
There is even a clock, and you can have variable like increase on a regular, periodically speed, and you can even have 2 clocks and they are like challenging each other. It's funny.
Yeah, this is... So in the example, it will be bind A to a clock, and then B equals 6, C equals A plus B. And then you'll see that it starts with A equals 1, C equals 6. And then every second it's self-updating, and C is increasing like 6, 7, 8, 9.
So that's a super elegant way to create animations, right? So as opposed to running it, creating a screenshot, then creating a GIF, and then you have the decision of how fast or quickly do I play it back, and oh, my machine is super fast, and this isn't quite right, and now I need to have a little 2x playback in my video player for my GIF, and that didn't quite work out. Kind of bind it to a clock and say, okay, let's make it a little bit faster. Is that the idea?
Yeah, stuff like that. You could like slowly reveal more and more of your data points on a graph. That sort of stuff.
Yeah.
Yeah, it's all about trying to find components that have the most like creative applications, right? This clock is really just counting 1, 2, 3, 4, 5, but because it's an integer and you can do everything with Julia, it's actually a really powerful component.
So I'm curious now, it seems like this could be used in many places, and Gerhard, you mentioned that you were using it for your course, but can you maybe tell me of a few other places where you've seen Pluto being used as an educational tool?
Yeah, I saw Pluto first as the online course in computational thinking. So this is on the MIT webpage. And I also know that some people use it for consulting because it's like Excel and you can show your clients directly how like graphs and figures change. I also use it in development of my perception algorithm for autonomous driving, where I can just directly develop my algorithm because I can directly see it.
Tell me more about that application, Gerhard. So it's not like you use Visual Studio Code. My first approach with Julia, I ended up installing VS Code. I used the extension and I was familiar because VS Code was my go-to platform for Python. So even for a serious programmer, you also start with Pluto as opposed to...
I did. So I also use Visual Studio Code for implementation or integration. But for exploring and developing, much more go for Pluto because in your cell you define your idea. You can also write down your markdown or formulas and so on. And you have this it's like a coding lab. So you want to explore things and change things and you get the reactivity. You have sliders and you have the plots. And I really like also to develop and brainstorm in Pluto notebooks.
Can you tell me more about the application itself that you're...
It's called AI for CSM. And we are building a robotaxi. So I'm developing the perception. So we have a car where there's a LiDAR on top. So this is a laser shooting 1 million laser beams around in 460 degrees. And they're measuring the distance when they hit the ground or any object. And my task is to process this data, this 1 million data points within a second in really runtime to tell where is an obstacle, where is free space, and give this data next to the intelligence module, which decides what to do: braking, overtaking, driving along. And so the other module is written in Python. And when I started at the company 1 year ago, I was quite free to choose how I work. And the cool thing is it works everything together. So I can develop everything in Julia. It's super fast. I work on a GPU, which helps me to process all the data. And there is a super cool Python bridge where I can switch the data between Python and Julia. Actually, Julia in our setup lives in Python. And if you send a variable from Python to Julia, it's not taking double storage, but it uses the same storage on your disk. So this is also cool. Yeah, and it's a lean, cool working. For me, it also solves this two-language problem because people before had tried to first they implemented something in Python, then it was too slow, then they went to some CUDA implementation, which is super hard to read. And yeah, I explained it before, you just push your variables to the GPU and it's like magic. And this solves the two-language paradigm. You have one language which is super fast and one language which is so easy to prototype. So I prototype in a very fast way and I'm super fast in implementing. So this is for me key why Julia is so cool and Pluto is, as I said before, it's like the touch screen where I really can experience, and it's like the coding lab, which I really like to use.
Yeah, there's something to be said, I think also in previous conversations, Fons, you and I discussed in saying that people use NumPy, but NumPy is not really written in Python, right? It's written in C. So there's a bunch of very smart people who had to write C library, they wrapped it around, and then everyone thinks they're using Python, but actually using wrappers in Python of C, right? And also many things in MATLAB that also holds true, and MathWorks is this ecosystem of generating C code to deploy it to different environments. But I think Julia, which is interesting, is a lot of the packages are written in core Julia. This mixing and matching of languages is not needed because by definition, it's already fast.
The best example is Flux, I think. So this is really funny. So machine learning, many people use PyTorch or TensorFlow. And if you look at the documentation of PyTorch, it tells you it's not written for performance. It's written to work very well and easy with Python. This is, I think, stated on the manual. And so my first machine learning experience was in Flux, and it's so easy to set up like some convolutional neural networks, and it's all in Julia. You don't have to think in different languages. It's one language, from prototyping to sending on a GPU to performing. So this is so elegant.
So then maybe to go back to the question of what areas are they being used. So I seem to remember Fonz, you were collecting use cases, and that's, I think, how you and Fonz got together. You shared some of your your Pluto notebooks. So can you give me a few more examples of the Pluto notebooks which are actually being used around the world? And is it for university students? Is it also for high school kids? Where do you see the main adoption?
What I know, so many people use it for teaching at universities, and also maybe to controlling some lab systems, because the sliders are super cool, for example, to change the temperature or something. And Pluto notebooks directly, as I said, maybe also in consulting. And
but is there a specific industry that you see it stronger? Is it like I don't know, is it geosciences, is it aerospace, or is it across the board?
There are some fields also in astrophysics, but maybe Fonz, you're more expert on that.
I think the answer is no. There's not a clear field where Pluto, like industrial field where Pluto is used more than others. But
cool.
That means, yes, it's being used everywhere. Yeah, it's being used everywhere. A really cool example is a company that uses Pluto to control a quantum computer. Like, they use all of these sliders, but also they make custom interactive elements, and they set up like the settings of a real quantum computer. I think that's pretty cool. Yeah, and then notebooks. If you want to see lots of nice examples, there's the Pluto conference of 2021. So you can search for PlutoCon 2021. And there were lots of talks, including Gerhard's, and that's how we met, of people just using Pluto however, like whatever purpose. And I was able to make some categories afterwards so that the conference seemed organized, but actually it was all over the place. People used Pluto for everything. There was a really exciting talk by someone using it for a pen plotter. That's like an old school graphing machine where you put in a pen and it moves a mechanical arm around in 2 dimensions. And it can move the pen up and down. And so it can make beautiful spirals and graphs, and it's great for generative art these days. And yeah, someone gave a presentation of using Pluto to prototype with drawings. So he wrote a function that generates a drawing with parameters, and then he could really quickly tweak those parameters, and then when he's happy, like clicks, and then bzz, it prints it out on paper. I think that was a really cool application in my eyes. And that's also, it's so nice that we run Julia, so people can do whatever they want, and they can make it interactive in lots of ways, because you have all of these different input components, like graphical components. You can make your own components with JavaScript. Those sliders and webcam inputs, they're not special because I wrote them. You could have written them. It's all public API. So you can also make different components based on them, or you can combine a webcam and a slider into a new component that is the webcam slider, or I don't know.
And I also know some really cool projects where you can use Pluto. For example, you can take an old DVD and make a spectrograph, and it's like you need some paper, some black paper, and you put like a grating and with a small slit, and you attach that to the camera of a mobile phone, and then you can analyze the spectra of a lamp. And you can analyze it basically. You don't have to install a thing, you just have to find the notebook online where you can just call it with your browser, and then you click on the make a photo button, and then you have spectral analyzer. Or you can attach a microscope. There is fold scope, small microscopes for $1, and you can do analysis, counting how many, I don't know, cells you can find, and the data analysis. So this is also a thing. Julia is super fast and perfect for data analysis.
I think that these are really cool examples, and the fact that there's a Pluto conference, this is super cool. And I was looking on the GitHub of Pluto, and you've got 4.4K stars, so this is a relatively high number for a relatively new package, if you will. Just out of curiosity, do you have any insight on how widely used is Pluto? Are we talking like a couple of hundreds, or do you have any numbers or an idea that you could share?
Yeah, let's see. The nicest thing for me is when people get in touch because they use it for their class, and then they get a sense of which universities are using it. Or sometimes out of nowhere, you end up on a website where the notebooks are written in Pluto, and you're like, oh, nice. One time I saw this notebook that did really extensive styling. Like, it didn't look like Pluto at all anymore. They totally went for their own style. I thought that was really cool. And then...
Yeah, and we have a Discord server where Plutonians, as I call them, can meet and ask questions and share their notebooks. And so a lot of in the Julia community works on Discourse, which is, I would say, an online chat program, and also on Zulip, where you can ask questions and also contribute to development. If you have the idea, hey, there should be a new feature for, let's say, touch input, a new user interface element in a Pluto notebook, then why not join the crowd and help developing it?
Tell me a little bit more about that. So I think it's very cool that you're receptive to that. So I'm going to play the devil's advocate, because in many open source projects, it's very unclear what happens behind the scenes. So someone says, I would like this feature, creates an issue. What happens to this issue? Is there like a team of you who are looking in this regularly, and then you have a meeting and say, issues 1 to 23, these are nice to have, but not going to happen in the next year? How do you guys end up prioritizing / deciding what the new things are going to appear?
Yeah, this is something I really had to discover, because it was my first open source project. And then all of this, it comes at you really fast, and you have to figure out how to deal with it. And also a lot of negative feedback. You have to learn how to not get upset about that, and how to still have a nice time writing software, even though some people don't enjoy it for their use case. So I think a really important thing that I discovered was that our project is different from other open source projects in that we have a really clear target audience, and this is beginner programmers. And this is a bit strange, because the people who come to GitHub and write really detailed issues are actually not our target audience, probably because they are people with a GitHub account, which is already on the edge of where we want to reach new people, right? Of course, we want the software to be great, and we want every bug report we can get, but for things like feature requests or complaints about workflows, it's often a weird case where those people who get in touch and write really detailed emails or issues are actually not the people we're designing for. And the people we are designing for, we mostly interact with them like one-on-one or over Zoom calls or stuff like that, like looking at students working in a class, or getting feedback from teachers, or teachers relaying feedback from their students. That's really what we need, like feedback from first-time Julia users. So this is also why on GitHub we send people in different directions when they open an issue. So for bug reports and stuff like that, it's all GitHub issues. And then for feature requests, we ask them to use the built-in feedback box. So if you open Pluto, if you install Pluto and you open it, at the bottom there's a little box where you can type feedback, and you can leave your email address if you want, but you don't have to. And then it just sends it to our server, so you don't need to create an account, because again, we want to reach people who don't have a GitHub account yet, and they can just type feedback right away. And it can be small feedback, or it can be something bigger, although the box is pretty tiny. And this, I'm really positive about this, like the feedback we get there. There's so much nice feedback, like even things like lots of people complaining that there was no dark mode. That was actually so useful to see, is this just one really well-spoken person complaining about it, or is it multiple people complaining about it a lot? And it was the second one, also some well-spoken people with some GitHub issues, but to see that it's normal people who actually want the dark mode helped convince me that we need it. And there's other cases like this where, based on the feedback, I felt, this is something that people actually need, instead of this is a well-spoken GitHub user that wrote a really critical comment. Yeah, it's also nicer for the stress factor, getting all of these feature requests on GitHub and then doing open development, not just open source. So really going into the feature request, explaining why it doesn't fit our use case or why it does, and explaining what the integration would be. That's a ton of work and a ton of stress, because if they go straight for the feature request, then that's what they want, and they are going to fight a little bit to get it. And that's just a really strange interaction to have between a volunteer who spends so much of their time working on something that they like and someone who just wants to get what they want. And so having this in our own servers is also nicer, because we can slowly see, are these requests accumulating? Is it multiple people? And we don't really have to explain whether we agree with a feature request or we don't. Yeah.
And it's also
Go ahead,
funny
yeah.
that
Yeah.
the traditional Julia community comes from a really like scientific background, and we want to create this bridge and reach out to school kids. And this is like scientific, and it's like you provide this small, elegant wagon, and they enter it, and then they find themselves in a rocket. Like they can also work on a supercomputer with the same code, and this is building this bridge. This is what really is exciting for me, that we enable people to to work or to have access to computing power on a cutting edge. This is really amazing. And concerning how to develop things and motivate people, because this is not a commercial project, that the work done is, there are so many volunteers involved. How do you motivate people to develop a new tool? I'm totally in for collaborative programming. So we have this Discord server. Like I ask some people who are able to do some stuff or have the expertise, and then we meet, and then we say, okay, hey, let's meet for a chat, and then we co-develop and see how this new feature could look like. So this is the way I like developing things.
Yeah, because I see there's quite a few volunteers, and I'm sure it's good to keep that inflow growing. But I really like this idea of data scientists are super good at programming, all these cool concepts, and even like version control is super powerful. Computer scientists, programmers live and breathe this, but there are many other fields that don't get exposed to that. So drawing that bridge to earlier people, I think, is a super powerful goal, and that itself feels like it's a good attraction, right? So many people in the world will eventually maybe have kids and say, okay, so how do I teach my kid how to program? And then, okay, so let me open up Python environment, pip install. You see the eyes of the kids going away. Okay, Papa, I don't know what you're talking about. So I really like
Actually,
the
I
fact
tried that last week with my niece. She's 13, and I wanted to install Python for her because she said, yeah, she's interested in Python. And then I could really see like her enthusiasm melt away when trying to get Visual Studio Code set up and all that stuff. And it's exactly what you said.
So I think that noble goal probably drives a lot of the people you have. And I remember one of the things that I first looked at the Pluto, because maybe I'm a person with GitHub account, right? I said, so how does these notebooks, how do they work under version control? I want to do a git diff. How does this work? Is this a good thing or not? And I kind of got hooked up on that. And I'm glad you've clarified, Fons, here, that actually you don't want university or high school kids to worry about that. That should not be their primary concern. So the idea that maybe you also cater for these things, but you can prioritize different use cases. So I think it's a cool idea to have that feedback box directly in the tool itself, and that drives cool things. Yeah, but that lends us to, okay, so we know where Pluto's come from, so like a COVID project that kind of evolved and now is growing like crazy. So congratulations on that. But you also mentioned earlier on that you've got some ideas of where it's going. So you have a 4 steps, and now you're going to make it into a 1 step. Can you disclose some of these ideas, or where's it going in the future?
Yeah, that's a great question. And I'm also thinking about this question myself, of course. And recently I'm trying to meet with all the contributors to see what their answer is, and also what they are motivated to work on, because you cannot do this on your own. And motivation, like the motivation of your contributors, is maybe more important than your own motivation. But I can talk about my motivations for the next year or so, is that Pluto is in a really good shape, and I think these first 2 or 3 years we worked a lot on technical stuff, the file format or reactivity or macro support or all of these technical things that had to be done and had to work, or making really important features work. But now it's getting to a point where it's a stable whole. It makes sense. There are features missing, but it's fine to not have them yet. But I think what's really missing now is a simple web presence. So a clear website that explains how to use it, what it is, how other people use it. We didn't have a website until a few months ago. So I'm working a lot on this, like a website that explains Pluto well and that shows it off in a nice way, and where you can try it online. And then I want lots of featured notebooks. So we have this idea of a featured notebook where someone's notebook is showing up on the main page, and everyone who uses Pluto can click on it and read it without having to run it. And if they want, they can run it and interact and all of that stuff. And those featured notebooks are also going on our webpage. So plutojl.org/featured, or I don't know the URL yet, but something like this.
We'll put it in the show notes. We'll put it in the show notes.
Totally, yeah. Just go to plutojl.org and then you'll find it. Yeah, so these featured notebooks, I really want like hundreds of featured notebooks where you can just spend the whole evening figuring out things from astronomy or economics, maybe philosophy, some mathematics. Like you could go into all of these scientific fields and find a notebook about it and interact with this science. And I think that is going to be really cool for a lot of people, and it might be a good resource on learning basic Julia, advanced Julia, or specific Julia concepts or packages. So I think it's gotten to the point where this is more important than working on Pluto itself, like showing what you can do with it. Because we keep finding, like we make a new feature and then I call with someone to show it off, and then they say, hey, what's that button you pressed there? And then I was like, gosh, it's a feature from a year ago. I just never told you. Yeah.
So let's say I've got my Pluto notebook and I am solving, I don't know, a Sudoku problem, right? So my cool algorithm of solving a Sudoku problem, whatever, right? Simple thing. How do I give it to you?
Yeah, just send me an email, fonts@plutojl.org, and send me an HTML export of your notebook. And there's a couple of requirements. Like it needs to run fairly fast, so if you use tons of packages, then we might not make it featured yet. But yeah, just send me your notebook and we'll look. So what's nice for you is that we will help you make the notebook even nicer. So we'll do a little review where we give you tips, or we make your code a bit simpler, or we try to help you illustrate your point. So that's a big advantage for you. And then the second one is, of course, it's going to be shown to lots of people. You can maybe get some kids excited about your scientific field, or you can draw people towards your package, other stuff like that. Yeah.
And you can also post your notebook, your example notebook, or really cool Pluto notebooks on our Discord server, where we have a channel for it.
Good. The community manager stepping in here saying, we can't have the bottleneck being fun. We need a community.
Totally.
No, I think that's very cool. And then just to maybe get an idea, so how many people are actually contributing? Is it just the two of you, or is there, how big is this development crew that we're talking about?
It's an active group of about 10 people, and then people come and go. We try to be like a nice destination for people looking for a new hobby. A big thing is, if you want to contribute, we have a weekly community call. Right now it's every Tuesday at 6 p.m. Central European time, but it might change in the future. But you can join the call. It's also on the Discord. You should totally go to the Discord. So first you go to, you go to our GitHub page, and then you search for contributing.md. It's a document explaining how to contribute. And from there you will find links to everywhere else. But we have this weekly call, and we have lots of open discussion places like Zulib, where people can learn more about our development. But yeah, I think it's a group of 10 people who contribute every now and then. And then there are more people that come and go. Yeah.
So I was also looking a bit on the website. Correct me if I'm wrong, but so the computational thinking behind MIT, MIT's got a big name and all that, but what caught my eye was Grant from 3 Blue, 1 Brown. There's a video of him using it, so that's also a testimonial of how powerful it is. So that was you guys very humbly forgot to mention that. That's cool. At least I found it interesting.
Yeah, Sanderson was invited as a guest lecturer for computational thinking. And then it seemed like he liked Pluto, so he used it for his lectures. And those were really nice, and I recommend checking those out on YouTube, Computational Thinking MIT or Julia. He gave lectures about image processing, and he used, for some of the lectures he used this classical grand style, or 3 Blue 1 Brown style, with those beautiful
Mhm.
animations, like flying around the math. But I was really honored that sometimes he also just used Julia code to explain things and Pluto interactivity to explain things. Because what's so nice about Julia is other people who don't know Julia can also read it, maybe, sometimes. At least
Yeah.
they can read it much better than if you had written that in MATLAB, C++, Python, or any of those languages. It's a really good communication tool. And so I think you could see that in his lectures, that he didn't always hide the code, which you could do. You could hide all of the code in your notebook and just make it interactive magic. But instead, he was showing code and he was tweaking code as an educational tool. And yeah, that's spot on. That's exactly how
Yeah.
we want people to use it. So that was super nice.
This is a great place to end this episode. I hope you found it interesting and it triggered your curiosity in some shape or form, at least enough to have a conversation with some friends and family about some cool, interesting insight of how MATLAB, Python, or Julia are actually used in the real world. If they do find it interesting, don't forget to tell them to subscribe to this podcast